Hello everyone, welcome to 𝑚𝑐Δ𝑇. Today we are going to do a question on thermal physics. This is a very common exam style question in A-level physics. It's a good question as well. So here's the situation. We have two metal spheres. One is made of iron, which is at 90 degrees Celsius, and the mass is 3 kilograms. Specific heat capacity of iron is given. Then we have a sphere of copper, temperature 75, mass is 2 kilograms, and the specific heat capacity is given as 390. Then you have a container of water. You have 10 kilograms of water at 20 degrees Celsius. Specific heat capacity of water is 4,200 joules per kilogram degree Celsius as usual. So the question is, when you transfer the copper and iron spheres into this water, obviously the water will heat up. The iron and copper spheres will cool down. They all come to the same temperature. They come to thermal equilibrium. The question is, calculate the final temperature of the system. And you need to state any assumptions you make. Please pause the video and give it a try. When you are ready to check the answer, press play. So in a question like this, you need to think about the energy transfer. Now, we don't know the final temperature. Let's call the final temperature is capital T. Now, we can think that capital T is less than 90, obviously, because that cools down. It's less than 75, but it will be more than 20. So, the energy transfer here is energy lost by iron plus energy lost by copper is equal to energy gained by water, because iron gives energy to water, copper also gives energy to water, and water just absorbs. Now, for all of these, the formula is E is equal to mc delta theta. So, energy lost by iron will be mc delta theta iron plus mc delta theta copper is equal to mc delta theta water. Now let's very carefully substitute the values. Mass of iron is 3 multiplied by specific heat capacity of iron 462 multiplied by delta theta would be 90 take away T. You take away T from 90 because we know T is less than 90. Plus M here is for copper, it's 2 multiplied by C. C is 390 multiplied by delta theta. Again, 75 is more than T, so 75 take away T is equal to mass of water is 10 kilograms multiplied by 4,200 multiplied by the final temperature is higher. T is higher because water heats up. So it will be T take away 20. And all you need to do is now solve this so you get the final answer. So from this point onwards, it's quite a bit of calculation, but it's pretty straightforward. You multiply these numbers and let's multiply out the brackets now. Now you can move all the T terms to the same side. So let's move them to the right hand side. And move this 840,000 to the other side. Like this. So you get to this one. And let's just divide both sides by this number so you can get your T. So the final temperature of the system is 23 degrees Celsius. Now, we can see the temperature has risen very little from the starting 20 degrees. That's because water has a very high specific heat capacity compared to both iron and copper. What are the assumptions? One of them is that no energy is lost to the surroundings during this process. That means all the energy lost by iron and copper are just absorbed by water. Another assumption that you can mention here, that energy absorbed by the container is negligible. Now, in reality, the container in which you keep water has a certain heat capacity. So it would absorb a certain amount of heat energy, because that will also come into thermal equilibrium with the rest of the system. But here we assume that it is negligible.